In this video, I'm going to show you how to add and subtract rational expressions with different denominators. Let's start by reviewing how to add the similar fractions. So we have here 7 over 15 plus 5 over 9. So what we do is we get the LCM of 15 and 9, and that is 45. For those who have forgotten how to find the LCM, you can do the listing method where we list or we express each number as product of its prime factors. So we have here 3 times 5 and we have here 3 times 3. Now to get the LCM, we list this as only one factor because it's common to them, and then we drop down all the rest of the factors that are not common to each other. So we'll have here 45. We can also use continuous division where we continuously divide 15 and 9 by their common factors until there's no more. So here we have 3, we divide that, and then there's no more common factor except 1. So we take the L shape here, like LCM. So we multiply 3 by 1 by 5 by 3, and that's still 45. Now we will use this LCM to make the fractions similar by making the fractions 7 15ths and 5 9ths equal to a fraction with a denominator of 45. So in this case, we find the missing numerator, so we can multiply this by 3/3 is the same as 1. So any number times 1 will have the same value. So 21 over 45 is the same value of as that of 7 over 15, only that 21 over 45 is in higher terms. So we multiply this one by 5/5. 9 times 45, 5 times 5 is 25. Okay, and then after that, we can now add, because they are similar fractions now, we can add the numerators. 21 plus 25 is 46 over the common denominator. So this is a vertical way of doing this. You can do that also horizontally. So we copy, we will use our LCM. So we can divide this. So we'll have the answer as 3, and then we multiply that. So we'll have now 21. The operation is plus. So we now have this 45 divided by 9 is how much? 5. And then we multiply it by 5. So we'll have 25. And then since we have a common denominator, which is 45, let me use white color. So 45, we just add the numerators. 21 plus 25 is 46. Okay, so now we use that knowledge in finding the LCM in adding monomials. We have here our denominators are x squared and y. X squared, y, and the other one is y squared. If we're going to use the listing method, so it's the same as x multiplied by x multiplied by y, and then we have y multiplied by y. So we take this as 1, and then we drop down all the rest. So our LCM is equal to x squared y squared. So we can use that as our common denominator, x squared y squared. The shortcut here is, if you are using letters like x and y, so x squared, you have your y and y squared, you just choose the one with the highest exponent. So for example, for y squared, this has the highest exponent, so you use it, and then you just copy the other literal coefficient. Now we make the fractions equal, or we're finding a fraction equal to 6 over x squared y with a denominator of x squared y squared. So we can use this. By the way, let me erase this part. Okay, so we can divide this. So, and then after dividing it, we multiply by 6. So for you not to forget it, you can already write 6 here. And then what's the answer when we have x squared y squared divided by x squared y? So the answer is y. And then we can already add 3 here, and then we put here the answer in division. So we have here x squared y squared over y squared equals x squared times 3. And then we simplify our answer. We have 6y plus 3x squared over x squared y squared. Or we can arrange them according to order. We have 3x squared plus 6y over x squared y squared. This answer is already in simplest form because you cannot find a common factor between the numerators and the denominators. Or we can also, but that will not matter. So I was thinking of getting this, the common factor, which is 3, and then we have x squared plus y over x squared y squared. But even if we do this, there are no common factors anymore between the numerators and denominators, so this answer can already be accepted. Let's try this example. So we get the LCM of A, AB, and ABC. So our LCM is, let me write that. Our LCM is, so these are all letters. So the highest exponent is simply 1, so it's A, B, C. And then we have ABC divided by A times 3. So we have 3 B, C. And the next, so the operation is addition. ABC divided by AB is C times 2. So 2 times C. Operation is addition. Let me extend our bar here. So we have ABC divided by itself is 1 times 1 is 1. Our numerators is already in simplest form, 3bc plus 2c plus 1 over abc. That's already the final answer. Let's take another monomial. So we have here our denominators are 12xy squared and 3x squared y. So we take the LCM of 12 and 3, the numerical coefficient 12 and 3. The LCM is 12 because that is the number that can be divided by 12 exactly and by 3 exactly. Now for our literal coefficients, the shortcut is we take the one with the highest exponent, so x and x squared, we use x squared. Y squared and y, we use y squared. And then we do the same process. We divide this, so 12x squared y squared divided by 12xy squared leaves us with simply x times 1 is x. The operation is addition. And then we have this 12 divided by 3 is 4. X squared y squared divided by x squared y. So we have here 4y, and then we multiply that with our numerator times 4. Let me show that again. 12x squared y squared over 3x squared y. So this is 4x and this is y. So this is our 4y here, 4y times the numerator 4. Now we simplify this. We have x plus 4 times 4 is 16y over 12x squared y squared. There's no more common factor between the numerator and denominator, so our answer is already in simplest form. In this example, we have our denominators as binomials. So we find the GCF, or we find the LCM of 2x minus 1 and x minus 2. So you can see there is no more common factor between the two numbers except 1. So in that case, our LCM can be taken by simply multiplying the two, because the only GCF is 1. So 2k minus 1, k minus 2. And then we use the same process. We divide this by this. That gives us k minus 2 multiply with the numerator. So it's always division here, and then after getting the answer, you multiply. So you multiply that by k plus 3. The operation is addition. Let's proceed to the next one. So we divide this by that. Our answer is 2k minus 1 and then times 6. Okay, so that is the first step. The next step is, let me extend this. We simplify. So we use FOIL method here. We have k squared minus 2k plus 3k is simply k minus 6, and then here we use distributive. 6 times 2k is 12k positive. 6 times negative 1 is negative 6 over 2k minus 1, k minus 2. And then we continue with this by combining similar terms. K squared stands alone. K and 12k is 13k. Negative 6 and negative 6 is negative 12 over 2k minus 1, k minus 2. We have a trinomial in the numerator. Let's just see if there is a factor common with the denominator. So k, I'm doing the numerator. So let's say this is 2 because there is a factor 2 below. So let's say k2, this will give us 6, 6k and 2k. There is no way we can get 13k. Okay, so that means we can stop there. That's already the simplest form. Same with the previous example, we have binomials in the denominator. So the question is, what is the LCM? To find the LCM is first to find the GCF. How will you know the greatest common factor or the common factor between the two numbers? So what you're going to do is to express the numbers first as factors by employing the rules you know about factoring. So in the first example, the denominator a squared minus 4 can follow the factoring using difference of squares. So this is the same as a plus 2, a minus 2. So now you have a plus 2 for the first factor and a minus 2. This is for the first factor, for denominator of the first term, and then the other one is a plus 2 So you can take this as 1, a plus 2, and then drop down the rest, a minus 2. So our LCM is a plus 2, a minus 2. So a plus 2 divided by a plus 2, quantity a plus 2 times the quantity a minus 2 divided by this is 1 times that. 1 times a is a. Okay, operation is addition. So this one, the whole thing divided by this gives you a minus 2 multiplied by b. Okay, so we simplify this. We have a plus ab. We're distributing ab minus 2b over a plus 2 quantity a minus 2. This example is a lot easier because these are already in factored form. There's no need for you to factor it anymore. So we can find our LCM by having their common factor listed as 1 and then copy the rest. So this divided this by itself is 1 times 2r is 2r. The operation is subtraction. Then we do the next. This divided by this is r plus 1 multiplied by 1. Okay, so we simplify. Let me use white color here. 2r minus 1 times r, negative, minus 1 times r minus 1 times 1 over r plus 5 quantity r plus 1, and then 2r minus r is r minus 1 over r plus 5 and another factor r plus 1. Okay, so it will be hard for us to find the LCM if we don't factor the denominators. So the first step is to factor the denominators. So I'll start with this one because this is very simple. The common factor between this is 3x. So if I factor this, 3x squared divided by 3x is x plus 3. So here, you'd probably be thinking, since x plus 3 is there, it might be a common factor. So sometimes you need to strategize. So if this is x plus 3, the other one is probably, since it's negative 15, I will need a negative 5 here. Let's check if FOIL method is correct. X times x, x squared. 3 times negative 5 is negative 15. This is 3x and this is minus 5x. So that gives me negative 2x in the middle. So this is correct. Now we can now find our LCM. So our LCM, what's common here? This, we take it only as 1. So taking it only as one number, we have x plus 3 and then copy all the rest, 3x and x minus 5. Now I can do the same thing we're doing a while ago. So this divided by this, I will have 3x left, because by the way this is the same as this, so I can just use the factored form so that I can easily cancel the factors that is common to them. So it's the same as 3x, x plus 3, x minus 5 divided by x squared minus 2x minus 15, which is written as x plus 3, x minus 5. So now I can cancel. I have only 3x, and then multiply this. We always multiply with the numerator, so times 2x. Now I go to the next. The operation is minus or subtraction. So I now divide this with this. So it's the same as saying 3x, x plus 3, x minus 5 divided by 3x, x plus 3. So I have x minus 5 multiplied by x minus 2. Okay, so I need to simplify, but I need room here, so let me erase this. Okay, so 3x times 2x is 6x squared, and then minus, I will need to use FOIL here. Since it's preceded by a minus sign, I will need to write the answer inside the parentheses. So I have x squared minus 5x minus 2x is minus 7x, and then plus 10 over the same thing, 3x, x plus 3, x minus 5. Now I can remove the parenthesis now. So 6x squared minus x squared is 5x squared, minus 7x is 7x, minus plus 10 minus positive 10 is negative 10 over 3x, x plus 3, x minus 5. Okay, we continue with this example. Again, we need to write the denominators in factored form so we can easily cancel out what's common to them. And it's also easy to find the LCM. So I'll start factoring this. This is the same as x minus 3 and x plus 3. Now, more or less, you know that either of them could be a factor of the first number. So I'm not writing the symbol addition or subtraction in the middle because I can play around with that. So if this is x, I need 2x to make 2x squared. And then if this is 3, I will be needing 1 to get 3. So 1, since it's a negative 3, they must be of different symbol. Now, if I multiply this, I will have 6x. If I multiply this, I will have x. But I need 5x. So that means I need to have this positive and negative to have a positive 5x in the middle. So, therefore, this is plus 3 and minus 1. Okay? Now, I can now use this as, I can now find the LCM. So LCM common to them is written as 1, and then I copy all the rest without common factor. And what's the other one? X minus 3. Okay, and then we do the same procedure. Divide, it's always divide here, divide, and then multiply. It's always the easier way to do that. So dividing x plus 3, 2x minus 1, x minus 3 by this, which is converted into this, x plus 3, 2x minus 1. I can cancel out what's common to them, so I'm left with x minus 3. But don't forget to multiply it with your numerator. The operation is subtraction. Then I'll do the next, this divided by this, and then multiply with that. So I have
although you can do that mentally, but I'm writing for the sake of you remembering the procedure. 2x minus 1, x minus 3 divided by x squared minus 9, which is the same as x minus 3x plus 3. So I have 2x minus 1. Don't forget to multiply with the numerator. Okay, let me erase this part so I'll have a room for solution. Okay, so we have here, I can use distributive for the numerator, 2x squared minus 6x, and then here negative 5 times 2x is negative 10x, and then I have here positive 5 over the same denominator, x plus 3, 2x minus 1, x minus 3. And then I can combine similar terms. 2x stands alone, minus 6x minus 10x is minus 16x, and plus 5. And then I have x plus 3, x minus 3, the order does not matter in factors, 2x minus 1. I don't think there is any more common between the numerator and denominator, because even if I factor this out, I will have the last numbers as 1 times 5, and there's nothing here. Oh, let's try 1. 5. Okay, if I use 2x minus 1, and then I have here x, so I will have here 5. So x negative, negative 10, negative 11. Okay, there's no more because I need negative 16x. So that is already the final answer. Okay, so let's do the same thing as what we have been doing. So x minus 2, that could stand alone. It's not factorable anymore. Not factorable, so that is simply x minus 2. And then this is a perfect square trinomial, perfect square, and this is twice the product of the factors, x minus 2 squared. Okay, so they are the same number, so we take note of the one with the highest exponent because this is simply 1. So x minus 2 squared divided by itself is simplified x. Operation is addition. X minus 2 squared divided by x minus 2, we have x minus 2. And then don't forget to multiply with the numerator. Okay, so we have 5x plus, let's distribute 4x minus 8 over x minus 2 squared. This is equal to 9x minus 8 over x minus 2 squared. Okay, for this number, what we're going to do is, again, to find the LCM. So let's factor this. This is simply GCF. So we have here 12 and 18. Common is 6x squared. Then we have 2x minus 3 times is 18. Okay. And then this one, 16 and 24, 8x. And then 2x plus 3. Now, to find the LCM, there's no common factor between this and this. So we'll just copy that. 2x minus 3 and 2x plus 3. However, here, 6x and 18x, the LCM is the LCM of 6 and 8. 24 now, 24, and then use the highest exponent, so 24x squared. Now we divide. Okay, this one divided by this, which is actually the same as 24x squared, 2x minus 3, 2x plus 3 divided by, this has been converted into 6x squared, 2x minus 3. So 24 divided by 6 is 4, 4, and so we have 4, 2x minus 3, plus 3. Okay, 4, 2x plus 3. But don't forget to multiply the numerator. Operation subtraction. So let me just continue this. Now we do the next one, this divided by this. So we have 24x squared, 2x minus 3, 2x plus 3 divided by 16x squared plus 24x, which is converted into or factored into this 8x multiplied by 2x plus 3. So we can cancel this out. 24 divided by 8 is 3x. So we have 3x and 2x minus 3. So 3x, 2x minus 3. Don't forget the numerator, which is x minus 2. Okay, let me highlight that. We shall not forget the given numerator. Okay, so to give us a little room here, let me erase this part and we will continue. This is quite long. Let me do the numerator first because it's starting to add the denominator to keep on adding the numerators. So let's have here equal. Let me do this first, FOIL method. So 4 times 2x times x is 2x squared. 3x, 3x minus 6x, negative 3x, and then minus 9. Then minus, okay, 3x. Let me do the FOIL here. 2x squared. Then I have minus 3x minus 4x. So minus 7x plus 3 times 2, 6. I'm doing the numerators first. Then I will just copy the denominator later on. So this is the same as 8x squared minus 12x minus 36 minus 6x cubed. Oh, my coefficient. Okay, minus 10 plus 3 times 7, 21x squared minus 3 times 6, 18x. Now I can simplify the numerators. So I have negative 6x cubed, and then this and this 29x squared, and then this and this one negative 30x minus 36 over, okay, this is our denominator, 24x squared, 2x minus 3, 2x plus 3. Okay. That will be enough. That will be too long already. Or we can try on factoring by grouping, but I don't think that will work out with our denominators.